Swayam Prabha. Digital India. Educated India.
Welcome to this course on transition metal organometallics in catalysis and biology. In this course we have been talking about olefin polymerization in the last few lecture. In particular, to begin with, we had looked into various classifications of polymers that exist, and these are primarily based on the polymer properties or their material properties. For example, if the polymer shows resistance to deformation, and then after some time with an increase in temperature they accept the deformation, that is one kind of behavior, and usually are called as thermoplastic. Similarly, there would be polymer which will be very flexible to deformation. However, later on when the deforming stress is removed, it remembers and goes back to its original conformation. So, those are elastic in properties. So, based on various polymer properties, we have gone through several types of polymer classifications that one encounter in the world of polymer chemistry. So, in this context, to begin with, in the last few lecture we had discussed about the following polymer types. So, in this we have looked into thermoplastic materials, we have looked into duraplast, next was elastomers, the fourth being elastoplastic materials, or called thermoplastic elastomers. And the fifth is called reversible duraplast. So, we have looked into the classification of polymers based along these 5 classes, and what we had seen that this classification has mainly been done with regard to the polymer properties, particularly with respect to applied stress and removal of stress. Also, we have looked into the various composition or types of polymer required for producing this kind of different polymer types, and they involves mainly the polymer with cross linking, or polymers with branching, or polymers with meshing. So, there is a deep structure, deep rooted structure function relationship of the polymer structure with that of the polymer properties. Now, with regard to olefin polymerization, the good thing is that all variety of this kind of materials can be produced from polyolefins, and that is why polyolefins have become so important. Now, with regard to polyolefins, we in the previous class we then subsequently focused on polyethylene, Polyethylene classification, and mainly this was done again mainly based on the density and the structure of polyethylenes, and they can be divided into three broad class types. LDPE, which is linear low density polyethylene. The next one is LLDPE, linear low density polyethylene. And third one is HDP, high density polyethylene. So, we have seen that how these three varieties of polyethylene can be classified based on the density, based on their structure and based also on their properties. Now, in today's lecture, what we are going to do is we are going to spend some more time on polymer classification, and this is particularly not from the material perspective, but from the mechanism perspective or the chemistry perspective. So, the two classifications that we had presented earlier in the previous lecture are from the material properties. That means that these are classified times based on the properties or behavior that each of these materials exhibit, whereas now we are going to look at the broad classification of polyolefin based on the mechanism or based on the process which are used for synthesizing these polymers. So, now this portion would be taught from a book which is very famous in polymer world, and request the audience or the takers of this course, the students, to please refer to this book. The title of the book is Principles of Polymerization by George Oden. Odian, George Oden. And this is sort of a very good book that talks about polymer, particularly from the mechanism, their classification and the perspective, and request the students to refer to this book for this part of the lecture. Third edition. Now, with regard to polymer classification, the other the common classification from the chemical perspective is are of two types from these are called either the first type is the polymers divided into condensation polymer and addition polymer. Now, this division is primarily based on the process which by which the polymers are synthesized. If the polymers are synthesized by condensation reaction, then these are called condensation polymers, and if the polymers are synthesized by addition reaction, addition of monomer reaction, then this is called addition polymers. So, let me just repeat, the condensation reaction for producing condensation polymers occur between the condensation reaction between two or between the monomers, individual monomers, whereas addition polymers are synthesized by addition reactions which also occur by addition of monomers. Now, the difference between condensation reaction and addition reaction is due to the fact that condensation reaction will have a small molecule byproduct like elimination of water or any other small molecule byproduct in the during the course of condensation between the monomers, whereas for addition polymerization there is no byproducts which are evolved as a part of the polymerization process. So, these division of condensation polymers and addition polymers are primarily based on the process which are used for producing the polymers. Now, there are another way of classifying the polymers that is that is based on the mechanism by which these polymers are formed. So, the top one is the process by which the polymers form, and the second one is based on the mechanism. So, under this category the polymers can be divided into step growth polymer, and chain growth polymer. So, this particular division is based on how the polymers are made, whether they formed in the steps like the individual, like it solely focuses on the mechanism how these polymers are produced, or whether the polymers are produced in a chain fashion. This is these kind of polymers are referred to as chain growth polymers. So, the take home message is that polymers can be divided or classification of polymers can be carried out at least in from three perspectives. One, from the material perspectives, in that category the polymers are graded based on the properties that polymer exhibit, and in that category we had looked into this thermoplastics, duroplast, elastomers, elastoplastic material and reversible duroplast. So, on that category, from that perspective it can be divided into those. Similarly, along the from the material perspective as well, polyethylene can be divided into low density polyethylene or LDP, or linear low density polyethylene LLDPE, or high density polyethylene HDPE. Now, apart from the classification which we had discussed earlier based on the material perspectives of the polymer properties, there are two other forms of classification can also be applied for distinguishing polymers, and these are from the chemistry perspective. Particularly one is based on the process by which these polymers are synthesized, the other is by the mechanism by which these polymer are synthesized. From the process perspective, polymers can be classified again into two types. One is called condensation polymer, the other is called addition polymer. Now, condensation polymer, as the name suggests, is produced by condensation reaction between monomers, which eliminate some small byproducts like water during the process of condensation. So, that is why they are called condensation polymers, which are formed due to condensation reactions with monomer with elimination of small molecule like water, alcohol, and etc. Similarly, from the process perspective, the other classification is addition polymers. Addition polymers are similarly formed by simple addition of monomers to give the polymer. And the second classification of polymer from the chemistry perspective is that of from the mechanism point of view, and from this point of view again the polymer can be classified into two types based on the mechanism which they follow for producing the polymer growth. And the mechanism can be of step growth polymers, where the polymer is formed as a step, whereas as several steps, whereas the other classification from the mechanism perspective is chain growth polymer, where polymer grows as a part of growing chain. So, with this introduction, let me just focus on the various classification from the chemistry perspective in today's lecture. And to begin with, let us start by looking at the condensation polymer and the addition polymer. The condensation polymer. Condensation polymers are formed from polyfunctional monomers by various condensation reactions with elimination of some small molecule example water, and this is given by the reaction diamine plus diacid giving NHR, NHCO, R dash CO, N OH plus 2N minus 1 water. So, the point to note in this is the following. What it says that condensation polymers are formed from polyfunctional monomer. So, there are two monomers over here, for example, this is A and it has two functional groups with this. So, this is one type of monomer A and the second monomer is B A because it is a different monomer and it also has two different functional group. So, the polymer which is made out of it is AB type polymer as a condensation reaction which happens, and all of this condensation reaction to happen eliminates water. So, the small molecule elimination is very much there because it is a condensation reaction. So, this reaction that we have just shown as an example of condensation reaction is a very famous reaction because this product was a big commercial success and it is called nylon polymer. So, nylon was made by condensation reactions where diamide and diacid react to give AB type polymer. So, and the nylon was a big commercial success in 30s and 40s and had lot of applications everywhere. So, this is a nice example where one can see this condensation polymer being made by condensation of two different monomers. Similarly, another important example of condensation polymers would be examples. We just saw nylon falls in this category and this was a big commercial success, and this was made from diamine plus diacid monomers, diamine and diacid monomers, condensation of these two gave nylon. Similarly, another big example of condensation polymers include a variation of this, and it includes diacids and diols, and the product the products are polyesters, acids and iol give esters. So, this was also a big success at the time of its discovery. So, there are what I mean to convey is that there are many processes which are formed, many important polymer which are formed through condensation process, and these polymers have huge commercial demands. For example, for the polyester, the reaction is between, so this is one monomer, polyfunctionalized monomer, H giving OH plus so here also what we see is that there are two monomers, one is monomer A which has hydroxy, and these are polyfunctional, it has hydroxy a moieties, whereas the second monomer which is monomer B, this is monomer B and this has diacid moieties, and they give AB a type of polymer. Another interesting polymer which will again that is also immensely successful commercially, that comes out of this condensation polymer is polycarbonates. So, these are some examples, nylon, then polyester, then polycarbonates, they arise out of condensation reactions, and all of these are important commercial monomers. So, let me just briefly give the process by which these polycarbonates are prepared. So, these are diol, Cl, NCl plus 2N minus 1 HCl. So, this polycarbonates over here is a reaction between the reaction between diol and diacid chloride and acid chlorides. So, this is can be conceived as a reaction between diol and acid chloride. Here this is an important gas which is phosgene. This is phosgene, very toxic, and this is monomer B with functional groups at the end, and monomer A this is monomer A with again functional group at the end, and what one gets is AB type of polymer, condensation polymer. So, with this we come to the conclusion of today's lecture, in which we have looked into various classifications of polymer based on material properties as well as based on the process and mechanistic perspectives. In this context, we have discussed about condensation polymers with examples, taking some commercially polymers like nylon, polyesters, polycarbonates, which are extensively used for commercial purposes and which are formed through condensation process. So, with this we come to an end of today's discussion on polymer classification. More of this polymer classification particularly from the chemistry process and chemical mechanism point of view would continue in the next class, and I once again thank you for being with me in this course in today's discussion, and I look forward to discussing more on this topic of polymer classification when we meet next. Till then, goodbye and thank you.